Hello, everyone. We're super excited to have you here tonight. We've been trying to get this meetup going for a while. I think Paul and I talked about doing something, and he was actually anxious to come visit Orlando. He was one of the amazing speakers at DevFest last year, and he wanted to come back to join our community again and talk to us. Unfortunately, given the situation that we are all in, we're going to have to do this one online. So Paul is excited to kind of present to our community again, and we are super excited to host him again. Um, Before we start, I'd like to kind of go over a few things. Um, this is a little bit about our community. Um, we we like to start talking about our code of conduct, and basically, it just comes down to being nice to each other, especially now, like everybody's sort of struggling at home and dying to kind of see other people um, without a mask and be able to shake hands and that sort of thing. But this is us. The guy with the guitar. That's Michael, Javi, and me, Hendrix. Um, if you have, any of these issues in our code of conduct arrive or at any of our meetup, feel free to contact us directly and see what we can do to help. Again, this is us. This is a way to contact us. This is our Twitter handle and our email. Also, our mission is basically to grow together, especially our local community here in Orlando. Um, about our speaker tonight, his name is Paul Ruiz. You probably saw his information on the meetup page. He's a DevRel for Firebase at Google. He's going to be taking a deep dive into Flutter and Firebase, how to kind of prototype something really quickly, which is something very interesting, especially now where you are home, kind of maybe have more time to play around with things and maybe working on your own projects. And this is a nice way to kind of, if you want to, have something in mind to put together. This is a great information uh, to get a hold on and put it into practice. And maybe, who knows, you have a successful project uh, in your during this crazy time in 2020. But anyway, without further ado, I'd like to welcome Paul. Thanks for joining us today. And I'm going to share your screen now, and we're going to switch to yours. Thanks. So,
Cool. Hey, everyone. Thank you for the introduction, Hendrix. So again, my name is Paul Reese. I'm a developer programs engineer on Firebase at Google. So today we're going to talk about two tools, Flutter and Firebase, and how they can be used for rapid prototyping. So whether it's at a hackathon with only 1 weekend to build something presentable, or even an idea for an app that you want to test out before really investing in it, a lot of us have been in a situation where we want to build something quickly that gets the job done. So during the normal prototype development process, developers plan out what their app should do and how it should function, research the feasibility of the idea, map out their architecture, pick their tools, and then build a clean, organized prototype, right? So yes and no. Some people stick to a very formal process, but when they're building out a quick prototype or a proof of concept app, most of us, myself included, just want to open up an IDE and start coding, and then we'll just kind of figure it out as we go along. Given this, I'm going to talk about the two tools that I mentioned earlier, Flutter and Firebase. Both of these are easy to use and address different development problems. Flutter is for client-side development, and Firebase is for the backend. Both are designed to be easy to use, and they are both well supported with content and documentation to make getting up and running as easy as possible. So while I wouldn't necessarily say this is a deep dive, this presentation is going to look at a lot of code and tools that will hopefully be helpful in getting you started with Flutter and Firebase. So while it might be a lot up front, I can't really stress enough that you don't need to memorize everything. All of the code that I want to show you today in this presentation is going to be available in the slides that I share after this talk. So I'll post them up on the Meetup page and Twitter and a few other places just to make sure everyone's on the same page. So what this talk isn't is a live coding exercise or a workshop. So as much as I love to do this presentation that way, I've tried a couple times, just isn't really doable with multiple instances of an IDE and an emulator and everything in between, trying to stream off of an entire screen. So Hopefully someday I'll be able to switch back to that, but for this case, it's just going to be slides with code and talking and whatnot. So what I do hope with this talk is to help you leave with the vocabulary to look into both these tools further when you're ready to build out a prototype and get up and running with these tools. So let's go ahead and get started with that. For building native apps for multiple platforms on top of C++ using a 2D engine called Skia, which is the same graphical engine used by Chrome, Android, and a few other platforms, all from a single SDK. Since everything is built from a single code base, you can create your prototypes for multiple systems, such as Android or iOS, without requiring specific developer knowledge about each of those platforms. Flutter is also completely open source, so not only is Google working on it, but so are many members of the developer community. So rather than being walled off from the internal workings of the tool, you can dig into the code to see exactly how Flutter is doing what it's doing, as well as send your own pull requests if you want to improve it. So far there's been something like 18,000 contributions from the whole global developer community into just Flutter. And that number just kind of keeps going as more people are discovering that platform and trying it out. So aside from Flutter being cross-platform, you're probably wondering when you should use it for rapid prototyping, especially since other tools exist that do similar things. So like most development decisions, it's basically an it depends answer. While Flutter isn't the only tool that can work cross-platform, it is designed from the ground up specifically for creating apps quickly. It's able to easily tie into device hardware using external plugins and packages that can be imported into your project, and uses widgets, which we're going to dig into a bit more here soon, to create UI components programmatically rather than requiring something like a layout file or a storyboard. One other feature of Flutter that I think is super valuable is hot reloading, so you don't need to restart your entire app to test small UI changes. Instead, UI changes will automatically be applied to your running app as you change various values. Following up on the it depends answer, there's also going to be times when Flutter isn't the right solution for you, and it's better to figure that out early on in the development process. So for starters, games are a lot of fun to develop, but Flutter just isn't really at a point where you can make most types of games quick enough to call it a rapid prototype. You'll need to write a lot of components from scratch that other platforms currently give you out of the box. And for that kind of situation, I'd recommend looking into something like Unity or some other game-specific platform. Additionally, calling native APIs directly just isn't super easy. Normally, you would write native Swift or Kotlin code and then use platform channels to communicate back and forth to the native level through a bridging process. So while this isn't necessarily a deal breaker, it is more work than just throwing some UI together and calling it good. The next thing to consider is audio support, or rather the lack thereof. So while audio isn't supported by native widgets, there are third-party plugins out there that can provide this functionality, but depending on your requirements, you may not be able to use third-party plugins if it's something for like a company or what have you, so that's just something else to be aware of. Which brings me on to the next point. So while there's a ton of plugins for Flutter, some third-party libraries that developers have grown to love just aren't really available right now. You'll have to weigh the necessity of things like that versus working with what Flutter has before deciding to use the tool. Fortunately, there are alternatives to most things, but we'll dig into that a little bit more later. Finally, Flutter doesn't have support for additional form factors like watches, televisions, and cars. So right now, Flutter does technically have limited support for Wear OS, but there's no support for things like tvOS. So like we've talked about already, one of the biggest draws to Flutter for rapid prototyping is that it's an easy-to-use tool for creating custom UIs. The first part of this presentation is where this talk just kind of starts to get into the technical side of things, as I want to give an overview of some of the ways Flutter can be used to build UIs. So when you're working with Flutter, everything is a widget, and all UI is described by widgets in a tree structure. One key term that you'll see often in Flutter documentation around this is aggressive composition, which essentially just means that aside from some very basic widgets, the widgets that you do use in your apps, either custom ones that you've put together yourself or that have come built into the platform, will be made from other widgets. So you can kind of think of them like Lego bricks, where you just connect them together to build whatever you want. So as a lot of you know, you can't really start with anything in software without Hello World, right? So let's take a look at this example to get an idea of how Flutter uses widgets to create a bare bones user interface. All Dart apps use the main function as their entry point, and in there you can initialize various components and start your Flutter application. You can also see a center widget in this example, which will center your content in the middle of the device screen. Next is the text widget, which, as you can probably guess, is going to just show some text. And then this text widget also has a few different properties that can be applied to it. The first one is the string that will be displayed by the text widget. And the second is a named optional property, text direction, that can be used to customize the widget. All said and done, you'll end up with a stunning example of a beautiful, simple user interface that does almost absolutely nothing. So before we really get into how to use some useful common widgets, ones that aren't just hello world, I want to divert for a moment to touch on how Flutter can be used on multiple platforms. We've all seen apps made with multi-platform tools, but they just don't look quite right compared to the system's standard UI, such as Android apps that look like they were designed for iOS. What makes Flutter handy here is that it's able to tell what platform it's on, so you can apply the proper UI elements for your app based on the OS. So here you can see an example that we're using the same exact app on both iOS and Android, but they look native to their respective platforms. So if you're trying to build an app fairly quickly, just for a prototype, and you want to show it to iOS users and Android users, it's pretty straightforward to actually make it look like an app that was designed specifically for them and not have to deal with that whole mental hurdle of, this doesn't look like an app for my phone. So this function is actually available through the Dart.io package that can be imported into your apps. When the user is on iOS, the platform.isIOS flag will be true. If the user is on a different OS, then that flag will come through as false. So there's also an isAndroid flag that does the same thing for that platform. So if you're like me and your background is actually in Android development, you don't need to feel left out, which tends to be a common thing with mobile development. So it's kind of nice. You can also see here that we're using a standard ternary statement here to expand the proper widget from whatever platform the user is on. After you've checked that flag, you can expand an iOS-specific Cupertino widget to have it look like a native component when on an Apple device. So for this example, we'll take a look at using an iOS style slider from that Cupertino package. You'll need to make sure that you import the Cupertino Dart package into your app in order to actually have this styled widget be available for you to use. So if the user isn't on an iOS device, then you can just expand a regular slider as part of the second option in this ternary operation. Finally, you can see that both of these sliders have properties that can be set on them. So while the base properties are the same in this incomplete example, there are some properties in the components, such as the background color property and some other stuff that only apply to the regular slider. So you'll want to check the documentation or the source whenever you use a platform-specific component to make sure that you're setting the correct attributes rather than just assuming they're always the same. And since that last slide, for the sake of space, use an incomplete code sample, I have included a complete sample for a slider here for everybody. So the value for the slider is a double that is saved outside of the widget. The active and inactive colors are set for the material design version of the widget, and the onChange property is set to maintain state as the slider is used. So one thing to pay attention to is that the onChange property isn't set, or if it isn't set rather, then the slider is going to be unusable. So it'll just be kind of grayed out and you won't be able to slide it and use it for anything. So like a lot of things in Flutter, this widget is pretty straightforward, but you will need to look through the source or documentation to understand why certain properties are needed and what they do. So the next component that I want to talk about is the list, since honestly, most apps are essentially just list and detail screens. So if you're putting together a prototype for something, you're more than likely going to have something very similar to this somewhere in your app. So there's actually a lot that you can do with lists, like setting them up for infinite scrolling, having items react to long presses, and adding various custom composite widgets to each of them, or that each do different things within a single list. So to keep everything simple for this example, we'll start by just looking at the code for a super basic list of generated text items with a circle icon. And then after that, we'll take a moment to look at adding a swipe to dismiss feature, just kind of similar to what you see in this example here on the screen. If you're coming from the Android world with recycler views and whatnot, you'll hopefully be surprised by how simple this actually is, especially when you're comparing to how Android uses the standard view holder pattern and decorators and everything else that goes in with it. So the first widget here is the scroll bar. While it's not necessary, it does provide, as you can probably guess, a scroll bar on the side of a list so the users know how far along in the data they are. After that is the actual list view widget, which provides the scrollable area that contains and controls the list items. This widget also has a collection of properties that can be set to customize the list. Here you can see that we're setting a padding at the top and bottom of the list view, though the only required property in this is the child array, which will house all the items that exist inside of this list. The next part is where this component gets a little bit more interesting. So while you can include a simple list of array data structures, list or array data structure of other widgets, there's also this great list.generate call that can loop a set number of times to create widgets for your list view. So in this case, we'll simply create 100 items that will be displayed in our app. Each of these 100 items will be made up of a single list tile widget, which implements the material design spec for list items. And this is all done for you out of the box, so you don't have to worry about all the details and whatnot that would go into it. It's generally used to display just kind of text on a leading item, like an icon for each of those list items. So as you might expect, this list tile has its own properties. The first one is the exclude semantics widget, which wraps a circle avatar. This will display the index from the generated list as an icon at the start of the list item, and since it's wrapped by an exclude semantics widget, it won't be read by accessibility tools like screen widgets, meaning that it doesn't add noise for users that need to use these tools. So it's kind of worth noting for this one that it will only exclude the text that's going to be in that circle avatar and not the text that will actually be displayed on the list. So essentially what you're doing is making this more usable for people that need to use those tools so that they're just not getting noise and whatnot from extra components being shown on the screen. It is worth noting, though, that you should use the exclude semantics widget very sparingly and only when there's a very specific and beneficial reason for your users so that it's there, just because you don't want to kind of go around your accessibility tools for your users unless there's like a really good, valid reason that's beneficial for them. So the final part of the list tile widget is in our list view is probably the most simple. So it's just a simple single text widget that represents the content for our list item. So while that wasn't very much code, it does create a simple list view for our Flutter apps. So I actually have this exact code running in this graphic, but I also modified it to include a swipe to dismiss feature. So we can talk about how you would do that and like just add simple things to your prototypes in your list, just to have a little bit more functionality than just, hey, here's some content that you can click on. So let's just go ahead and kind of dig into that next here. The core of this functionality is yet another widget. So in this case, it's a dismissible. What's nice about this is that we don't need to replace anything in our current list to make swipe to dismiss work. The dismissible widget just takes the list tile widget from the last section and adds it as its own child. If we ran our app at this point, each item in the list view would be completely swipeable and would also be removed from the list view if swiped off the screen. So while optional, the background property does help let users know when they are swiping away on an item by changing what appears behind the list item during the action. So in this case, I've added a new container widget that sets the background color to a very light green. You can also see, or you can rather also set a secondary background color if you want the user to see a different one when they're swiping from the left over to the right or vice versa. So one thing that's worth noting here is that since the background property accepts any widget, you can do some really fun things that are kind of interesting in this area, like loading in an animated GIF for the item's background. So while that doesn't necessarily mean you should, it is kind of fun just to see what you can do and the amount of creativity that you'll be able to apply through Flutter just because of the functionality of widgets and their interchangeability of them. So definitely want to recommend this though for like an actual app just because the performance hit is going to be kind of crazy, but it's kind of cool to know that you actually can do it. Cool. So now that we've looked at what we can do with the background of a dismissible, let's get into a couple more properties. The first is key. This is a required property that needs a unique value to keep things in order while removing items from your list, as it interacts with the actual data structure driving the UI. To keep things simple, you can usually just use Flutter's unique key class to assign a unique key to your dismissible list item. Finally, there's the onDismiss callback. So while this isn't really required by the dismissible, it is useful when you want to display something to your user to let them know that they've removed an item from their list. This is also where you'd notify your backend that the user has removed an item if it's hosted remotely. That way it doesn't show back up for the user the next time they open up their app. And then you can kind of keep some consistency between what the user is doing and what information is actually stored off in the cloud somewhere. And then since they're fairly often the widgets that are actually used in list views, I wanted to wrap up our general discussion of widgets by briefly talking about the cards design pattern. So like most widgets in Flutter, the snippet is pretty lean. The size box means that each card will have a predefined height. And that size box will wrap a child card widget, which sets some general properties for the card, like the shape and basic behaviors. Next up is the child of that child, which in this case is an inkwell. So the inkwell is kind of an interesting widget as it's what the card uses to figure out interactive touch areas. You can also set touch area colors, such as the ripple effect in Android, by setting the splash and highlight colors here as properties within the inkwell. If you don't want these to show up, though, what you can do is set these properties to colors.transparent, and then you won't have that ripple effect if it's something that you don't want for whatever reason within your app. And then finally, that inkwell has its own child, which is the actual content of the card that the user sees. So in this example, it's a custom composite widget called travel destination content. Despite the complexity of the widget that we've abstracted away here, you can see that you can add any sort of widgets that you'd want into your card. So similar to how we were using the Sparky GIF for the background of our dismissible, you can do the same exact thing with any kind of widget that you would want to put into your card. So overall, this snippet is just kind of a great example of how Flutter uses a hierarchy of widgets, though, to build UI for your users. So far we've covered a handful of widgets, but we haven't even broken the surface on how many are actually out there. So to learn more, I really recommend checking out the Google Developers YouTube channel to find out, or to find the Widgets of the Week videos, and to check out the official widget reference documentation at flutter.dev. So I'm actually not on the Flutter team, I'm on the Firebase team, but I actually think Flutter's documentation is just amazing. So if you get a chance to go through there and to see what else is there, it's pretty great. And we're actually going to dig into some of the other documentation and projects and whatnot that are out there as well, just to make getting up and running with Flutter a little bit faster. So now that we've covered a handful of common widgets, let's get into some stuff that's a little more interesting and useful when it comes to learning the platform and getting your prototype started. So the first tool that's super awesome, I actually just really love it in general, is the Flutter Gallery app. So this app is entirely open source and available on GitHub, and I'll have the link at the end of this presentation for everyone who wants to just pull it down and check it out. But since it is open source, that means you can grab whatever functionality you like out of it to throw into your prototypes. It goes over a collection of widgets that you can use in both Material and Cupertino stylings, and has a lot of other useful features that you can mess around with in this Playground app. Each widget section in the Gallery app includes a descriptor, and you can bring up the code that you used that was used to create that section. Each widget page also has an icon at the top that will take you directly to the official documentation for the widget that you're looking at. So additionally, there's also a variety of tools that you can use that will show you how to do animations, media playback, or just display different things like the stock colors and whatnot in Flutter to help you get your apps put together even faster. So the Gallery app also includes case studies, so you can see how common features work together in a more of a big picture scenario, rather than just the one-off widgets and whatnot that you normally see in sample apps. So here you can see a staggered grid view, hero animations, which is the ones where it's little and then you click on it and it expands into the next page. Circle animations, different types of a single list, and a few other useful items that you just are just here in the screenshots. So this is great when you're trying to put together a quick prototype, as you can get examples of animations, interactive components out of the box, rather than spending your time trying to dig through Stack Overflow, blog posts, and a whole bunch of other one-off sources when this is all just kind of compiled into one place. And then kind of going back on what I had mentioned earlier about the documentation and how amazing it is, I did want to talk about the Flutter Codebook. So this is basically just a, it's codebook, so it's documentation that contains various code samples or recipes for common tasks that you might run into when you're working with Flutter. So this is just a sample of what's there, but you can see that there's a lot of great content that you'll use in almost any app, such as animations, designs, different elements for that, and networking, and some other stuff. So again, I'll have this link at the end of the presentation, and you'll be able to pull it from there and whatnot when it's posted. Or you can just look up Flutter Cookbook, and it's like the first link that comes up on Google. So the next thing to talk about are plugins, which are essentially just a fancy word for libraries or modules, and are kind of one of my favorite things about Flutter as well. Because the development community is so active and passionate about the platform, they've created thousands of open source plugins that can be used in your apps to easily accomplish tasks without having to reinvent the wheel every time you need to do them. So you can find most of these plugins by using pub.dev, which is a site created by Google for searching through plugins and finding their documentation and source code. So with that, let's just go ahead and take a look at a few plugins that are out there and how you'd actually implement them. So while there's a ton of great third-party plugins out there, I figured I would start with Google Maps, since it's actually one of my favorites. And it's also just kind of the go-to whenever you want to display location information for users. So for this section, we'll go over the code that I used to make this exact demo image. So Google Maps functionality is all wrapped by a Google Map widget that can be displayed on the screen. So this widget has the bulk of its functionality handled by the onMapCreated future method. So if you're not familiar with futures from other languages, they're basically just one of the ways that Flutter handles asynchronous operations by figuring out what the app should do before an asynchronous action, during that action, and after that action has finished. So if you're familiar with Android development, then you can kind of think of these like async tasks, but a little bit less awful. Features will come up a few more times during this talk, though a really detailed look into this feature is a little out of the scope for this presentation. So this method is triggered once the maps data has finished loading. The example for this presentation will load the location of Google's offices around the world as a list of objects that will then be displayed as markers. Once those office locations are loaded, the map data structure of markers will get cleared, and then we'll loop through each of these offices. Each office will then be converted into a Google Maps marker that designates the office's location, name, and address. We can also add an action to OnTap, such as bringing up a navigation screen or displaying additional information about a specific marker location. Finally, we'll take each marker and add it to the global map data structure that we cleared earlier. So back to the Google Maps widget, we can set the initial camera position and zoom level. So in this case, it's just going to be a very high-level view of the center of the centered in the middle of the Atlantic Ocean. So it's just 0, 0. So it's going to be just right off of Africa. And then finally, we can add the set of markers to be displayed onto that Google map. So you just basically pass that map data object into the markers property for the Google Maps object. And I'll just kind of go back so you can see, again, what this will look like. So again, it's centered into the middle of the Atlantic Ocean, and we have markers for each of these office locations. And as we zoom in, we can actually see that there's like a circle with an outline and whatnot around each marker, which I don't think I put that into the code for here, but it's pretty straightforward too. It'll be very similar to other stuff. But if you click on it, it's just going to display the region as a little toast message at the bottom. So nothing too major, but the code for it is very light, and it's just kind of nice to have that example there. Cool. So next up is the Flare Flutter plugin. So this is a tongue twister, so bear with me. Flare Flutter is a third-party plugin that I just kind of thought was too cool to not include into this talk. So this plugin is great when you want to animate icons, buttons, or other items in your app to add some extra kick to your UI, which is always great when you're trying to sell an idea to someone or show it off for hackathon judges. So it's worth noting that you can do some of this manually using native widgets like Animation Builder or Transform, but it's just not nearly as easy as using this pre-made library that kind of does all that for you. So using their animation website, Rive.app, you can stage out animations that will then get converted into a vector animation file that you can export and run in your app. So overall, it took me roughly like 20 minutes of watching a tutorial on YouTube to learn how to make this exact fading and spinning star. And once you know how all of that works together, it's super easy to just put together more animations that you can throw into your application. So once you have your vector animation file exported, using it as simple as initializing the custom Flare Actor widget in your app, and then assigning it the animation file that you want to run. So this is the actual exported vector graphic file, as well as just the widget that'll be displaying this graphic and whatnot. You'll also notice that I'm using the animation title as Go in one of the properties. So what this is doing is actually calling the animation that I set from that Rive app. I don't know if you can see my mouse or not, so maybe. But you can see that the animation is actually called Go, so I'm just basically giving it that exact name so it knows to start that animation, which is the spinning and fading star, whenever I want to have it displayed. So while we've talked a lot about rapid prototyping for apps, it's becoming more and more common that people need to make prototypes that consist of an app with a hardware device. So for this next section, I want to briefly touch on FlutterBlue, which is a third-party plugin that helps you communicate with Bluetooth devices using a Flutter app. So while I won't go into a lot of detail here, this is an area worth knowing for people that need to make things with make like IoT prototypes and other hardware devices. So I just wanted to include it for a little bit more kind of completion. But again, full-on detailed view of all this is a little bit outside the scope of this talk. So the first thing every Bluetooth app needs to do is scan for advertising devices. You can do this by calling start scan on a FlutterBlue instance. You can also, and probably should, set a timeout duration so the scanning stops after a period of time. Next, you will listen to for results to be returned from that scan. And then you can act on those results, like saving a particular device based off of its name or RSSI value. RSSI is the received signal strength of a device, so it's basically just how strong is the signal from that Bluetooth device back to your phone and so forth. So you can do some weird things like measuring distance with a math formula and whatnot with that, or just other useful things. Then after saving your device, you'll probably want to connect to it using the connect method. And then you can discover the services that are being broadcast by that Bluetooth device. Depending on your setup, you may also want to loop through each of those services to do something with them in your app. One thing that you might want to do is pull each characteristic or piece of information from the broadcasted service. So not only can you read those characteristics, but you can also asynchronously write back to your hardware device by using those characteristics. The final thing I want to cover with Flutterblue is that you can actually attach a listener to characteristics as well. So they'll be notified anytime new data is pushed to a characteristic by another device. So this allows your app to stay reactive when dealing with the real world and kind of makes it a little bit more useful when you're actually working in that IoT space. And then to wrap up our introduction of Flutter, I want to talk about one of the more common tasks that you'll run into when you're building a new app, which in this case is just retrieving data from the internet and parsing a JSON payload into Dart data objects. So this sample will go over a simple list app that pulls data from the Etsy API to display inventory amounts for each listing in a single shop, though the same idea can be carried over to countless other common scenarios. So the first thing you want to do is use a feature builder in your app, which you may remember is a specific component in Flutter that lets you decide which widgets to show during or after loading data. So in this case, I'm using a new method called future listings. And this method is asynchronous. And then what it's going to do is it's going to return a future object with the type of listings, which is a custom object that represents the array of items coming from the API. This method will use the HTTP package to get the data from our API endpoint. And if that endpoint returns a 200 success code, then we'll use the JSON.decode method to convert the response into a JSON object, which will then convert into a listings object. So this is done from a custom object that I created earlier called listings, using some Dart magic under the hood that converts a JSON map into a list of objects with a type of dynamic, which are essentially just kind of undefined generics. Once we have the data from that future, we can do another conversion to switch the list of dynamic objects into another custom object. In this case, it's listings, or listing, which is just an individual item from the earlier listings array using similar JSON conversions. So this example also sorts the list using a simple A to B comparator operator. So while the sorting operation isn't necessary, I just wanted to include it in this case just because it is a little useful snippet of code that I figured would be valuable for people when they're trying to pull down data and display things into a list. So after all that, we can create a new list view of list tiles, just like we did earlier in this presentation. So for the last part of the sample, if there isn't any data in the future builder, such as during the time the data is loading, then we can just display a circular progress indicator until the results are available. It's also good practice to handle error cases in the future builder, but I didn't do that in this case right now, just because of space and time and so forth. That would add some complexity, and I don't know, I could probably include it later, but I didn't think it was super pertinent for right now. Cool. I'm going to go ahead and just check the comments here in case there's any questions before I get into all the Firebase side of this.
Gonna jump in. I don't see any question. Does anybody have any question? Feel free to post them on our YouTube stream. But I do have a question.
Cool.
Do you have any comment on SMS? I don't know if you're going to cover this, in the future slides, but SMS authentication using Firebase.
Yeah. So I'm not going to cover it in this presentation. Honestly, I haven't used it enough to have a really good opinion on how it works and whatnot either. So that's something I'm going to be playing around with later, but it's just, I don't know it very well.
Okay. I was just interested in knowing that if there's any charges in terms of, do you have to get a specific number to use, or you use your own number? Do you have any thought?
So just in general, I think there are charges for SMS. Let me see here. I'm gonna just pull up an extra thing here. How many people are on the stream? I don't want to take up everyone's time with this, but if it's a pretty small crowd, I can just divert.
Let me look. I don't think. Yeah, if you want to move on, yeah.
Okay. I'll just go ahead and display this real quick then. So SMS authentication, phone auth in general, you get 10,000 a month for free, and then depending on where you're sending it to, the price is going to be different. So it'll be like 6 cents per verification on top of that.
Awesome.
But you still get that 10,000 for free. So this is actually just a general Firebase thing, not necessarily Firebase Flutter. And because Flutter itself is just built on top of the actual SDKs that already exist. So
awesome. Let me hop off and let you continue.
Cool. Sounds good. Yep. Okay, cool. So for the next part of this, I want to go a bit into Firebase and how it's used with Flutter through Google's open source plugin, which is called Flutterfire. And you can also find that completely on GitHub as well. So first, let's just go over the official pitch for Firebase. So Firebase is an application development platform with a mission to help app developers succeed by using Firebase products. Firebase accomplishes this by taking common problems and developer tasks that occur during a product's lifecycle and makes them easier to solve, be it by providing more information about your apps and their performance, or providing tools to handle complex problems like security and network connectivity when storing data. Oh, looks like we got a question here. Let's see. From Dan, for a web dev thinking about dipping a toe in a mobile, would you recommend learning Flutter over something like React Native to start? Personally, I haven't used React Native too terribly much. I just really like Flutter just because the documentation and whatnot's there, but React Native may have more of a community around it. I haven't actually checked into that too terribly much. The big difference that you're going to notice here, though, is that Flutter itself runs natively on the platform. So rather than through like an abstraction and whatnot that you would have with React Native. So it's a little bit more performant in that sense. It really just depends on what you're more comfortable with, though. If you're seeing more of a use out of React Native, I say go with that. If you want to just try Flutter because widgets are awesome and some of the other things about it are awesome, I say also go with that. I am really just going to be whatever's best for you. I don't have an opinion too much on one or the other. Cool. All right. Let me go back to here. So Firebase is divided into 3 main categories of tools with specific goals. So the first one is to help you build better apps by making complex coding processes easier. The next one is to help you improve app quality by helping catch issues early and fixing them quickly. And finally, it'll help you grow your app by understanding how other people are using it and engaging with them in a meaningful way. So as you can see here, there's almost 20 different products within Firebase. So while that may seem like a lot today, we're only going to look at a subset of all these Firebase features that are going to be the most relevant to rapid prototyping and building something quick. So again, here the goal here isn't to overwhelm you, but rather to let you know what's available when you need it, so you can go and figure out all the details and whatnot about it later on with at least that starter vocabulary. So before you can start diving in and using Firebase in your apps, you will need to create a new project. You can do this at console.firebase.com and basically just type in the a project name and hit next a few times, and it'll get you set up with the project's console dashboard. The next step will be linking your apps back to Firebase. So for this talk, I'll only touch on Android and iOS processes. So for Android, you will need to enter in the app package name, which you can find in the Android manifest.xml file in your project, and potentially the SHA-1 certificate for your signing key. So one thing to note, though, is that the SHA-1 certificate is optional, and unless you absolutely need it for certain kinds of auth or dynamic links, I would just avoid using it because it can cause some headaches with migrating your app to a different project, or if you want to use multiple apps with that package name and SHA-1 and so forth, it can just be a little bit of a pain unless you absolutely need it. So if you don't, I recommend just kind of skipping over it. Let's see here. So after all that, you'll need to add some code to your build.gradle file for both core Firebase and the specific Firebase product that you're going to want to use. You will also be provided with a Google Services JSON file through this whole setup process that will just be copied into your Flutter app. So the iOS process is similar, if not a little bit easier. So you'll put in the bundle ID and then add some info to a plist file in your app and install the pod files for the products that you want to use. So after that's done, you should be golden using Firebase on both iOS and Android with your Flutter app. So the first feature I want to go over is authentication. So while it's not the most flashy feature, there's always that one hackathon judge that's going to ask you about security, so you might as well just toss it in since it's easy enough to use. So Firebase authentication will allow your users to log into your app using a username and password, a phone number, a third-party identity provider like Google or Facebook, or a few other options. So for simplicity, I'm just going to go over a few of the more commonly used authentication features. So let's go ahead and get started by discussing user authentication using an email and password, since it's one of the more simple options and kind of one of the more commonly ones used as well. So the major part of the setup process occurs in the console. Aside from adding your app to Firebase and updating your plist or including your Google Services JSON file, you will need to enable each type of Firebase authentication that you want to use within your app through the Firebase auth section in the Firebase console. So after project setup and enabling auth, you can go back into the code for your app. Using email and password sign-in is actually super easy. The first thing you'll want to do is register your user's email and password, which you can do by calling the create user with email and password method on a Firebase auth instance. This will also automatically log your user in once they've registered for that first time. If you want to sign a returning user in, you can use the sign in with email and password method just as easily. So next is the email link authentication. This authentication feature takes an email address from the user and then sends them a link that they can use to sign in, proving that they actually have access to the email address that they've used to authenticate within your app. So just like the email and password method, you will need to enable email link sign-in rather, from the Firebase console. So this is actually an additional option under the email and password method. So you just have to go in there and activate the little appropriate slider and save it. I don't know if you can see my mouse or not, but it's that second slider there next to email link passwordless sign-in. So you'll also need to enable dynamic links in the Firebase console, as they're used for associating your app with the user's email via that sent link. So you may remember from a few slides ago that enabling dynamic links also means that you need to include the SHA-1 certificate with your app. So if you want to enable dynamic links, you'd have to go back into your project and actually add that SHA-1 for the signing certificate to make sure that this is going to work out as you would expect. So when you're ready to sign your user in, you will need to email them a link using the send sign in with email link method while including the information for either iOS or Android, like the bundle ID or the package name, as well as the dynamic link for your Firebase project. If everything goes as expected, they should receive an email like the one in this screenshot that contains a sign-in link for your project. Clicking on that link should open your app on the user's device. When this happens, your app will automatically call the did change app lifecycle state Flutter method when opening. That's kind of a full one too, but this is just a lifecycle state method. So it's kind of similar to on resume or on pause in Android, or is it did start, I think, or I'm not super familiar with iOS, but there's a few of those as well. You can check to see if the lifecycle state is resumed and if there's a dynamic link associated with the opened app. If there is, then you can just handle that use case. So generally the way you would want to do this is by calling Firebase auth sign in with email and link method to retrieve a Firebase user. And then finally, you can update the app state data. The final auth type that I'm going to go over is Google sign-in. So from my own experience, this is actually the easiest of the third-party authentication methods to use, but they also sign my paycheck. So, I might be a little bit biased. So first you'll need to instantiate the Google sign-in object and then call the sign-in method on it. If the user's device is able to use Google sign-in, then they'll be prompted with a sign-in dialog similar to this one. After the user has selected their account, you'll receive a Google sign-in account object. You can use this to call authenticate against Google's identity provider service. Once the user is authenticated, you can retrieve your auth credentials from the Google auth provider. And then finally, you can retrieve the Firebase user using their Google authenticated credentials. So additionally, if the user has been previously authenticated, you can actually retrieve their Firebase user using the current user method here. So I just wanted to kind of include that for completion as well. So next I want to talk about the two database options available on Firebase. The first one, real-time database, uses a simple JSON tree structure to store and access data. This data is stored and synced between users and devices, and the main goal is to provide a backend data storage solution without having to go through the whole tedious process of setting up your own database server, authentication schema, REST endpoints, and everything else that just kind of goes along with setting up a database normally. So the first thing you'll want to do to use the Firebase real-time database is create a Firebase database object in your app. You can then create a reference to a specific node in the JSON tree data structure. So in this case, the node is called messages, and it's a child of the root node. So you can actually create as many references as you like, such as in this part of the code that creates a reference to the counter node, then reads the value from it once before printing. So this is actually not associated with the messages node, just to kind of show you that if you have a real-time database setup, you can pull from multiple parts simultaneously rather than having to only use one part of the database per device. So after you have your reference, you can associate it with a listener in order to take action on any data changes as they happen. Finally, I want to introduce a new graphical widget from the Flutter library called Firebase Animated List. So this works like a standard list, but it'll animate as items are added or removed from it. And it works specifically with Firebase references to listen for data changes without having to tie everything together. And I think, let's see, is it this example? Yeah, so this is actually an example of that animated list. So you can see as something is added to it from the back end, or if you're just hitting that little plus button, it'll kind of fade in and fold and whatnot as you're taking things out of it or putting them in. So the second option is Cloud Firestore. And this is a database tool that allows you to group data using a document collection structure for straightforward access. So it offers many of the same advantages as the real-time database, such as real-time syncing, offline support, and scalability. But it also supports basic queries in addition to direct data access. So one thing that's important to remember with Cloud Firestore is that it can be used in conjunction with the real-time database, as each serves its own unique purpose within your app. So while one will have strengths in one area and one will have strengths in the other, there's no reason to pick one or the other. You can actually just put both of them in your app, wherever it actually makes sense. So like most things in Firebase, it only takes a few lines of code to do the most common actions, like reading and writing data in this case. So by first getting an instance of the Firestore object, you can retrieve a child collection from Firestore. Once you have that collection reference, you only need one call to add a new document item to it. So here we're just calling that add method with a value of hello world inside of our message, and then giving it a timestamp for that created at time or value. You can also use another call to retrieve all the documents from that collection one time. So despite those two operations being super simple, let's also take a look at something that's a little bit more complicated, like listening for changes in your data. So you can do this by creating a stream builder object that listens to a specific path in Firestore and updates whenever new data comes down. So while we won't get too deep into what a stream builder is, you can kind of think of it in a similar way as futures in Flutter, except they're activated anytime new data is sent over into them. So this object can then check to see if a data snapshot is available. If it isn't, it can return a default UI widget. Let's see, do I have a default in here? I don't think I do in this case, but that's okay. Oh, I do actually. Yes, it's that loading text, so we're good. So other than that, you can retrieve the data from that snapshot if it does exist. And then using that data, you can update your app state and UI. So in this case, we're using the length of a data snapshot to define how large our list view should be, and then displaying list tiles in that list using the actual documents that have come down. And then since this question always comes up after discussing real-time database and Firestore, I just wanted to add a new slide in here to hopefully clear up some things. So essentially this is what's the difference between Firestore and real-time database. So both of these tools are actually using different data structures. So the real-time database uses a JSON tree to store everything, and then Firestore uses documents and collections. The real-time database also supports a presence feature, so you know when users are connected to specific nodes, and you can kind of keep track of that way. So if you need two users to be connected and listening to the same data, you actually know when that's happening. Then one of the bigger differences is that Firestore also supports more complex queries when retrieving documents when compared to the queries that are available in the real-time database. And then in regards to the location, the real-time database only supports the US Central region, but Firestore actually has a variety of regions that can be used to make data transfer more efficient for your users, depending on where they are. And then finally, there's the scaling and pricing to consider. So Firestore automatically scales really easily, just kind of automatically out of the box. It allows 1 million concurrent connections at a time, whereas the real-time database requires sharding if you want to go over the 200,000 concurrent users being connected, which honestly doesn't sound like a huge number, but for concurrent connections, we rarely run into that as an issue too, which is pretty nice. And then down to pricing and whatnot, real-time database is going to charge a little bit more on storage and bandwidth use, whereas Firestore charges for reads, writes, and data, and less for bandwidth and storage. So depending on how your data is being used, you might want to go with one or the other, depending on just the actual needs and whatnot for your application. If you're just working with like a small-scale rapid prototype or whatnot, or for a hackathon project though, you'll almost never, I would say pretty much never, go over the free tier limit. And if you did, then it wouldn't be too terribly much. If you do run into an issue with like a coding bug or whatever, you can also let the support team know, and we'll see what we can do to help you out with that. So while we've talked about database options already, sometimes you do need to store and serve user-generated content, such as images or audio files, directly in your mobile app. So you can do this using cloud storage for Firebase. Uploads and downloads are handled by the Cloud Storage SDK and are resumable, making them more resilient to changes in network connectivity. When a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resuming, which can be critical when dealing with the kind of network connectivity often encountered on mobile devices. Downloading content uses a similarly robust system, allowing users to retrieve their data once a connection is successfully reestablished. Once the user's content is uploaded, it can be shared with other users of your app using the same SDK. And since you will likely run into situations where only certain users should be able to see or upload specific content, you can use Firebase's security rule system along with Firebase authentication to restrict content according to your app's requirements. When you want to upload a data object to cloud storage, you can get a reference to that storage path and then create a storage upload task by calling put file or put data on your storage reference with the item that you want to upload, as well as any metadata that you want associated with that item. You can also save a reference to that task in order to pause, resume, or cancel the action. Downloading a file is also pretty easy. So you can specify a storage reference for that file that you want, and then you would just get its download URL. Once you have that, you can pull down that file using an HTTP request, like we have discussed earlier when we were talking about that Etsy list app. Once a response is received, you're going to retrieve the information about that file and then use it in your app. And then next up, we just kind of have, sorry, end of that sentence, kind of funny. Cloud functions for Firebase, which are single-purpose functions that are executed in a secure, managed environment for your Firebase project. They are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database or interacting with various other Google or external services. So these are great for handling just kind of backend logic in your app without having to set up a whole complicated backend. Kind of goes back to the whole Firebase thing of just an easy backend as a service to use without all the stuff that goes into setting up your own system. So to provide a quick example, I have this function written using Node that is hosted via Firebase Functions. When it receives an HTTP request, it'll get the date and respond with a hello message, as well as a current timestamp. You can call this function directly using Flutterfire's HTTPS callable object with an optional data map. And then you can listen for the results asynchronously to update your app's UI. So also at the last FireConf, we released a new product called Extensions. So I guess that's actually coming up on a year ago now here. So, but essentially what these are just pre-made functions that handle common tasks for developers without having to reinvent the wheel. So you can find them in the console to see what can work for your app and then kind of make decisions on which ones you want to install and how they'll be used, just to make things like resizing images, translating text, shortening URLs, some other stuff, just kind of easy by just a couple clicks of a button and then calling that function. And then while it's the only product that I'll talk about today that isn't in the Firebase build grouping, app distribution is great for rapid prototyping when you need to work with non-developers. So you can upload your APK or IPA file and add either a single person or a group in the console so that people can receive an email and download your app without having to go through the Google Play or Apple stores or just plugging their phone into a computer and dealing with that whole authenticating process and whatnot. That way they can give you feedback and they kind of help you work with your app before, if it's going to be publicly released. So this is just really great when you're working with designers and whatnot too, where you just want to send them the latest version of your app so they can say, hey, move this list over, add padding, change the colors, what have you. So the final thing I want to talk about is Firebase ML, which allows mobile developers to enhance their app's user experience by applying machine learning. Firebase ML provides a variety of models that can be run quickly from the cloud with a high level of accuracy and detail. So the out-of-the-box models allow developers to recognize text, label objects, and identify landmarks. Developers can also take their custom TensorFlow models and run them through Firebase's easy-to-use APIs. Firebase ML is a little bit more complex than other Firebase products, but it's still not too bad. So for this example, the image and image rotation parameters are found prior to running this method, and how you retrieve an image will vary depending on the needs of your app. So you can actually find a great sample that retrieves an image using scanner utils to get the camera stream in the Flutterfire GitHub repo. So once you have all the necessary data, you can call process image on your Firebase ML object to get everything just kind of started and running. The two methods here that aren't defined in this snippet are concatenate planes and rotation int to image rotation, which awful names, but they are what they are. Both of these are helper methods that you can find in the GitHub repo. But in short, they simply manipulate the image data so they can be used to analyze properly by Firebase ML. All right, so we've covered a lot today. So if you want to learn more about Flutter or Firebase in depth, then the top few links will give you a ton of information and resources, like code labs and videos. So for Flutter, again, I highly recommend the Flutter Cookbook and just their documentation in general, because I love it. You can also find more information on all the features available in Flutterfire on GitHub. Also, all the plugins and whatnot that I talked about earlier with Flutter are on GitHub as well. We have Twitter for just updates and whatnot as new articles and meetups and whatnot are coming out. And then, yeah, our docs and whatnot should be continuous up to date. So again, my name is Paul Reese. I'll be posting the slides and what this up on Twitter, and I'll also post them over to the meetup group. I'll be looking at questions and whatnot now, but you can also reach me on my email directly there or my Twitter. And I'll try to answer questions there as well if you have something that's a little bit more in depth, or you just want to discuss later on if you think, oh, hey, I should have asked about this. So cool.
If you have any question, please post them on the YouTube. I know there's a little bit of delay, so when I don't know if the video on the message posting is sort of in sync, but anyway, that was really awesome. Thank you, Paul.
Yeah, no problem.
I think this is the first sort of Firebase Flutter talk that I've seen where so much ground, you cover so much ground. Like I feel like I know like every single step, or at least a piece of everything that you will likely going to need almost in every scenario.
Oh, awesome.
I love that you put a little bit of a snippet where I could say, hey, I will keep this as a reference. So I hope you make the slide available. I would love to share that because it is a good reference. If you're working on a project or anything, you will always look and find a little bit of a snippet and kind of help you with whatever it is you're trying to do. I think we have a question.
Cool.
It says, can you talk about offline support for Firebase? I think you mentioned that.
Yeah, so I mean, pretty much everything with Firebase will have some kind of caching or whatnot for offline support. So if somebody is using Firebase and then they end up going offline, whatever was previously pulled down will still be available for them. So they won't get the live updates, but they'll still be able to function with what's already been available. And then with things like Firebase storage, if they need to, if they're in the middle of uploading and they end up going through like a subway tunnel or something and they just lose that connection, then it'll try to re-upload again once they do have connection. Same with downloading that file as well. So basically it'll kind of queue up anything that needs to be done while offline so that once something is available again, it'll try to run through it.
By the way, while we wait for the question, I want to add here, I worked on a project recently where we built the whole thing, multi-platform application using Flutter, and we had the web hosted on Firebase, as well as the using Firestore and Firebase authentication, and it really worked really smoothly. Like,
oh, awesome!
It's good to hear. It's amazing how simple like it is. You just kind of grab the a plugin and you're golden.
Nice.
All right, we got a couple of questions here from Brian. Can you talk about the offline support for Firebase? I think you mentioned that anyway. That's the first question. And the second question, assume that's handled automatically, and that's something we as developers have to handle.
Cool. Yeah, so I think we answered the first one just a second ago, but as for the automatically part, yeah, everything is handled pretty much within the SDK and is all hidden away from you, so it'll just automatically be applied and whatnot, so you don't need to do anything manually. There might be like one function to call to turn on offline support for real-time database and some stuff, but I'd have to double check on that. But other than that, you're pretty much golden.
I'll throw you another question since I've been working with this scenario, these two technology, especially recently. Is there anything, I don't know, tips and tricks or anything in your mind that you could help with in relation to messaging? I know there's like if you look online, and this is one thing that I did prior to this project was look documentation and information online regarding using Firebase messaging with Flutter. Found a few conflicting information, but just wonder, like, what's the common problem that you see people have?
So one of the bigger problems I've heard about is just the delay that you're going to get if you're sending tons and tons of messages. So if you're sending what is like 200,000 or something at once, just the way that you have to deal with that, where you just kind of cycle through them and do them in batches and some of the little things like that. That is probably one of the bigger issues that we've run into. To give you a more definitive answer, though, I'd probably have to go look into a couple things just to see what our common issues are. So I actually help run the support team. So I do get a lot of these tickets in to see like what problems people are running into, but there's so many things that I see that I'm just like, oh yeah, I should probably write that down.
Cool. The other thing that comes a lot is it's about rules. Like when you're writing those rules, and I got to tell you, I not an expert, so usually I kind of luckily Firebase documentation is really good, I think. But sometimes you like if there's things you want to do specifically with rules, you're like coming back from like SQL Server database and other sort of database system where you could say, okay, I just need like if this, then that, and the other, and like make sure that this data only show to these type of users and that sort of thing. And is there any catch there that you see most often?
So rules are actually one of the things that we're trying to work on a little bit more just to help people out with figuring out how they work. So I actually have on my to-do list for someday, kind of like a recipe book for security rules. One thing I would recommend is maybe just playing with the security rules emulator, though, so you're not testing against real data and whatnot, which let me bring this up here too. Let's see. Yeah, we actually have an emulator now set up for security rules that you could use. So something that get into.
The last question, actually, what are some good practices for setting up security rules for cloud, Firestore, and storage?
So it really depends on what the necessities are for your app. So I tend to be more of a block everything and then allow the use cases that you do know to be a little bit more exclusive so people can't abuse it as much, rather than just kind of opening everything up and then blocking cases that you know are going to be bad. Just because there's always going to be somebody that's going to figure out something that you weren't expecting. So I think that's kind of the biggest one I would recommend.
Cool. Yeah, I got a question. Yep. I've been diving into Angular, 100% Angular, the framework. Is there support for Firebase with Angular?
Not officially, but I think there is an SDK out there. So the way Firebase works is we really don't care what platform you use to access it, as long as you're accessing it. So if you want to use Angular or anything else that's out there, we have like the admin SDK if you need to make your own REST calls and whatnot to Firebase, or if somebody has made a third-party library to access Firebase, then we're totally cool with that too, and we'll try to support it. At least as best as we can. Yeah.
Hey, we got a question from Louis. What are some good practices for setting up security rules for cloud, Firestore, and storage?
Yep. So I think that's the one that we just answered a second ago as well. So that
I'm
was.
sorry, I'm
Oh.
behind. There's a delay on my side, I guess.
Oh, that's cool. So I have heard of people using this one in regards to your Angular question. So it's this Angular Fire library. We support it in the sense that we support JavaScript. So nothing super directly related to this library in particular. But if you have just Firebase questions while you're using it, we would support that.
Awesome.
Cool.
Is there any other question out there? Okay. Well, if you don't like at the moment, there's a whole contact information. You can always reach out to him or up to us. We will pass that question along. And we will, I'm assuming we could publish the presentation somewhere.
Oh, yeah. Yep.
Is that okay?
Yep. So I'm actually going to copy the slides and I'll put the link up on Meetup, and then you can share whatever.
Perfect. Thank you so much. Let me talk about upcoming events. If anybody.
It looks like there was one more question that just came through.
Oh, go ahead.
Cool. So let's see. If you have Cloud Firestore and Cloud Storage and Firebase, are they interchangeable? So I wouldn't necessarily say they're interchangeable. They handle different things. So Firestore is going to be more text objects and that sort of thing in documents, whereas the cloud storage is going to be more like blob type of data. So audio files, videos, images, that sort of thing. In Firestore, you actually can have references back to those stored like buckets of information though. So yes, in that sense, but they're two different products that do fairly different things.
Cool.
Cool.
All right. So this is stuff coming up, upcoming events that we have in our community. DevFest Florida is coming up November 14th. It's going to be a virtual event, obviously. But you can find information here. There's the official website. The call for speakers is still open. So you're interested in talking about any technology. Doesn't have to be Google technology that you're working on, you're interested on. Please submit your call for a speaker. We'll welcome your talk. Hint, hint. Poll is open. Our call for speakers. So if you're available, I'm sure you're super busy, but I will. What is it? Shame plug or
That's cool.
Yeah. Anyway, so we have the call for speaker is open, and that's the official site. There's some announcements that we'd like to make. So we were granted, especially for DevFest Florida, the Orlando Technology Community Support Program. We were awarded some money actually to help bring the community and talk about businesses and startup. These are some of the other groups and organizations that were also awarded some support. But we were as well, and we're going to make sure we will have something special for those of you thinking of starting a new business or working on a startup, of trying to navigate your way around being more entrepreneurial. The other thing we'd like to kind of give a shout out or mention is other community events in our community here in Orlando. Get Develop It has a Get in the Game event on Wednesday, August 26th. That's tomorrow. And Code for Orlando has the National Day of Civic Hacking on 2020. That's Saturday, September 12th. We also like to thank our sponsors, GDG, Google Developers, Firebase, and Google has been very supportive of our group, as well as Signature Consultants, Orlando Economic Partnership, JetBrains. This is us. We kind of put this together over the last few weeks. So we're working on DevFest Florida and any other upcoming event. You could check out our meetup page. So thank you so much. Paul, if there's anything you'd like to add before we sign out here?
No, not that I can think of. Well, actually, no. Tomorrow there is a Flutter and Firebase talk that's going on with the like our virtual talk, so you can actually find those off of like the Firebase's official Twitter account. They posted a link for that. That's gonna be a little bit more hands-on. So the person who's gonna be presenting is gonna go over building a couple small apps using real-time database and Firestore and some other stuff with Flutter. So if you're a little bit more interested in the implementation side of things, there is that. And then other than that, I am posting the slides right now for this, so they'll be up on the meetup here in a couple minutes.
Awesome. How about you, Javi? Anything you want to add? Anything that you're working on?
I definitely would love to see Paul in DevFest. It's definitely informational. I mean, I love Firebase. I think a lot of people will get a lot of value from your presentation. So.
Oh, awesome.
You're putting him on the spot. Sorry.
I'm sorry, Paul. But, you did an awesome job. You did. I mean, you gave so much information. It was awesome, man. I think everybody would love to hear this.
Yeah, no, I'll definitely check it out. I mean, I did it last year. I loved it out there, and then I've done the Space Coast one as well, and that was also awesome. So I just kind of like your development community out there in Florida. So.
Well, you're welcome to definitely join us on DevFest.
Awesome.
Yeah. Personally, I'm gonna keep a link somewhere of the presentation because I think it's a good reference for when somebody kind of have a question regarding any topic. I think this presentation is very, it almost covers everything that you could think of.
Oh, awesome.
You need to when working on a small project. That's amazing. Thank you so much again. Thank you for those joining us online and our community here in Orlando and those watching from other places. Thank you so much and have a good evening. Bye.
All right.
Thank you, guys.